This is the Unreal Engine implementation of a C++ library I've been writing. This is just the overview of it and a demonstration, and then I'll go in depth with how the C++ works after the demonstration. So first of all, we've got the event begin play, which just constructs a widget which looks like this. It's got the instruction, the current level, and the percent bar, and then it initializes the API. Now we can see that was the wrong thing. We can see the API initialization output here because I wrote an output logger. This is what I've been using to debug this, and it gives me some useful information because I have complete control over it. Anyway, begin play then sets the level to 1, so we start from level 1. There's a custom event here called fill bar, which just checks whether the current percent is equal to the max percent, which gets set later on, and if it is, it increments the level because that level is done, and if it isn't, it increases the percent a bit at a time and plays a sound to go with it. This probably isn't the most efficient way of doing this. I kind of just threw it together as a demonstration of the more interesting parts of the code which use the Amazon Web Services API. Here's the actual interactive part, if you will. So we've got Y and N for yes and no, and those just print a string so you know which one's been called. It updates it updates the current level entry in the table, which I will show you in a second, with either a yes or a no, affected by the boolean there, which is just being passed in, and then it gets the items so that you can calculate a percentage from it. Now, I was going to write some complex logic here for it to figure out that it's which choice you made, but I decided I didn't care. I was just going to throw it in like this because it just needs to demonstrate the point, really. So it will get the item and it returns both yes and no as float values, even though they will always be whole numbers. It returns them as floats so it can then calculate them as a percentage, which it does. It adds them together, and then if you chose no, no gets passed into the divide, and if you chose yes, yes gets passed into the divide. It's not majorly complex. It then sets that as the max percent and sets the percent to 0 before calling the fill bar function, which goes through, gets the percent. It's pretty simple, but it's the underlying stuff that's more interesting. You can see here, this is the list of numbers. These were all just thrown together with a random number generator on a for loop. In fact, that is, if I can remember how to use this, not like that, I guess. Oh, there we go, like that. Sorry. You can see down here there we go. The for loop that I used, it has a first index of 1, the last index of 55, because there's 55 levels here, and then that just does a random number between 1 and 90, and adds them to the item and then waits a second so that it can finish everything up. So that's all of the simple overview stuff. We're going to be starting at level 1, so I'll demonstrate level 1 and 2 so you can see both sides working. Currently we're on 14 and 32, but once we increment no, which I'll do first because it's on the left, that will be 15 and 32. So just to calculate the number we're expecting, we've got 15 plus 32, which is 47, so then it's going to be 15 divided by 47 times 100. We're going to be expecting about 31%, I believe. So let's run that. 31%. Cool. And then we can refresh this and see that it has incremented no. So this time I'll do yes, so we'll have 33 plus 71, which is 104. So then it's going to be 71 divided by 104 times 100. So we're going to be expecting about 68%, depending on how this rounds, and I can't remember how it rounds, but we're expecting about 68%. Ta-da! So that's it working. It will go through, it does exactly the same thing for every level, and that's all. It's quite simple, but the underlying code was fun to write. If we now look at the output log, we can see that it initializes the API, and then you can see where it where things happen. So I call the update item, and it updates the item, at which point it tells me that the item was updated successfully, and then it returns the level. The count is debugging information for when I was trying to get it to return values. But you can see it returns no 15, yes 32. It could return the level as well, because that's stored in the table, but seeing as we already know that, I don't bother. And then you can see it does this for 33 and 71. So looking at the underlying code for this, it's just a function library. There's the libraries, there's here's the header file. So here we can see all of the things that are involved. There's this, which is the output handle. That's how I've been handling debugging information. There's add item, which overwrites anything in there. So if we were to call the add item function on, say, level 1, it would no longer, and give it the values 4 and 2, it would no longer be 15 and 32. It wouldn't add 4 and 2 to that, so it wouldn't then be 19 and 34. It would be 4 and 2. So that would perhaps be more accurately overwrite item, but it can also be used to add new items to the table, whereas update item just updates existing items. So calling update item like we do will update with the value passed in, and the way I've been using it, it's more of an increment item, so perhaps these functions could be better named. But that's the update item. Then there's the query, which takes a level as input and then gets the pointer reference to the float values for yes and no, and returns those out, which looks in Unreal Engine like that. Integer in, float values out. And then there's init API, which doesn't take any arguments and doesn't return anything. It just initializes the API. So going through, we've got some debugging information, which is the get time, which is how we get the time at the start of each output information, and then just the way that works, which is very simple. So we create the output handle, which is the OF stream, which means it can write to the file, and then we give it a file to write to, which is f unreal eos output.log. Then make it push immediately to disk so we don't have to flush any buffers, and then say that the output log has been started and the init API has been called, which is why those are the first two things spat out into the output log. That's the basics of the output log, so I won't mention that anymore, other than maybe just glossing over that there's some debugging information there. It constructs the options object, which is of type STK options from the AWS library, and calls the init API function with these empty options, but this means we can then give it options later. So we create a client configuration object, because we aren't the API, we're a client interfacing with the API. And we give that EU West 2, which is the region we're currently in, and then create some credentials, because we also need credentials, and those have an access key and a secret key. These are very, very secret, and I probably shouldn't be showing you them, but it's fine. This is a test version of it anyway. And then construct a new Dynamo client object. The new operator in C++ is quite interesting. It can be used for very nefarious purposes. If I just I write the function void leak, then while God, I can't drive, true, the way with one line of code using the new operator, it would be int myVar equals new int 32. That, any number in those brackets will do. That's a memory leak. If I ran that, it would just start using RAM, because of the way the new operator handles memory management. It allocates things to the heap rather than the stack, so it's not dynamically allocated, and then I have to be responsible for tidying that up. Luckily, we are okay with using it here, because the new operator throws things on the heap rather than the stack. But we need this client object to be persistent for the entire runtime of the program. So, and we only create it once, so it's no big weight on the memory. And we can, if I needed to use something briefly, I could absolutely use the new operator and then remember to close it, because C++ doesn't have a garbage collector like C# does. But as it is, we can just use that because it needs to be persistent for the entire length of the application, or for the duration of the application's runtime anyway, and it gets closed up with the application. So it ends up being okay, and we give the client the credentials and the client config object. So we've now got an object which is kind of the way we're going to interface with the API. That is persistent, which is just means that now exists, which is why this is called on event begin play, so that all of this stuff exists when we need it. Once all of that's been created, we can do whatever the hell we like. So we've got the add item function, which, as I say, overwrites things, which is why it takes 3 inputs: a level, the level we want to overwrite, a yes value and a no value. And if this is the thing I've added, if the Dynamo client doesn't exist, or is, the Dynamo client does exist because it's initialized at the start. If the Dynamo client doesn't have an object, we can see I initialize that right at the top here, but if it doesn't have any value associated with it, not object value, it won't do anything. It will just X out so that we don't get any crashes. This is just simple exception handling. Otherwise, as long as Dynamo client exists, it will debug the information. It constructs some AWS strings because those are the values it takes. And we don't want these to change inside the program, or inside the function, so we're going to make them const just in case. Probably don't need to, but it is a safety precaution just in case. And that just takes the level, the yes and the no. It creates an item request and then adds the table name that we're looking for, and in this case the table is initialized right at the top because that's always the same, and that's test, and the key is always going to be level. It's not always in other tables, but in this one it's always going to be level. So really I do need to pass the value of level in, my bad, sorry. Yes, so we've got key value, but the key is always level. So we've got the table name, which is test, and then attribute value, AV, gets the number, the key value. We get the YV, which is the yes value, and NV, which is the no value. And these are all set N because they're setting numbers. And then we add item, key, AV. So name, value of, for example, key, which is, as we've established earlier, level, and then the level number that we passed in, which is 1, for example. So level 1, yes, 12, no, 37. We then create an outcome object, which we're just going to call result because it's the result of the push. And using a through pointer to access the Dynamo client, we're going to stick the item in the server with the put item request object as the argument, because that's holding all of these bits of data that we've put in. If the result isn't a success, it's going to output the error message to the log, or it's going to just output that it worked. And that's all the add item does. It's quite simple, quite nice, quite easy to use. Update item is a little bit more of a hassle for reasons that I don't fully understand, but it is. So we just, if the Dynamo client doesn't exist, don't do anything, but otherwise create the key and the key value, and then we've got a choice name. If the boolean that we passed in is true, choice name is yes, otherwise it's false, because we've got a yes and a no, so that can be represented as a boolean. It then just creates the update item request, same as before, and gives gives them attribute values, and that's all fine. This is where things get a little bit more fun. We create an object called 1, which has the value of 1, and now we need to construct a SQL, or not a SQL because it's a NoSQL database, so it's kind of pseudo-SQL expression. So we construct an increment string, which is incr, and then the update expression is set choice name, the variable, which we've got, is equal to choice name plus incre, which is 1 plus 1. And that's the update expression. So then we can assign the variables so that that update expression, when it finally gets used, actually means something. Things like choice name, and what that means. That's assigned to the variable choice name. And we pass that into the update request. And the incremap, which is equal to the value 1, all gets passed into the update request so that it knows what that NoSQL function does. Then it constructs a result and spits that out into the output log. This might look a tiny bit different to the last one. That's just because it's not all on one line like the last one was, because it's a slightly longer string, because I added update failed with error code, which I probably, thinking about it, should do on the other one, because that's more helpful debugging information, but that's unimportant. It's just what it spits out into the log. Get item is, again, a little different. So we've got an input and 2 outputs, and what that does is it constructs all the objects just the same, and then what it's got is a switch case. So we've got an integer called x, and we've got an integer called count, which starts at 1. Now this is because of the way the get item function works. And what that does, we don't here have, oh, here we go. This is how the default expression in the example code looks. It spits out i.first and i.second.getN. Now, this is a bit fun because if we just try and use i.second.getN, it complains about the type, I think. This was something I had a bit of trouble getting working, but it complains about the type, the object type of second. So using a little bit of magic, we assign x as string to int, so it takes i.second.getN, which, even though it's getN, returns a string, counterintuitively, and turns it into an integer, string to int, s to i, and passes in i.second.getN. So now it assigns no as equal to x, and then spits it out and increments the count. That is on case 2, because case 1 is the title of the thing, and we don't want that. Case 3, it does the, oh sorry, no, case 1 is level, first is the title of the thing, i.second is the value. My bad, but we don't need the levels, so I don't bother going through the rigmarole. Then it increments the count, and because we're inside of a for loop, for every item, it will go through again, because there is another thing that it's trying to spit out, and it does exactly the same thing, even with the same variable, because we don't need x anymore, so we can overwrite it, but this time yes gets assigned instead of no, and if somehow we've got out of this set of things, then it's going to go, oh god, the count's out of bound, and it's going to just break out. If the, let's fold these to make it slightly easier to read. Yeah. So if item size is not greater than 0, it's not found the correct item, and if the result is a failure, it spits out the debugging information. And that's all of it. That's all 212 lines of this function library. It is quite a simple function library with a surprising amount of annoyances gone into it, but it works. We have access to this database in the server, and we can make push requests, we can make pull requests, and all such things. And we can take those pull requests and put them into nice little graphs with audio cues.